Rightio, let's make some magic. Our goal here is to move our paddle, and to do that, we need to have our paddle linked to our mouse. And I'm going to outline for you the problem and the solution. I've talked about this a couple of times. You need to break it down. What's our design problem or our design goal? And then how do we solve that? So our design goal here, in other words, our problem, is to move the paddle on the x-axis in line with our mouse cursor. That means that as I move my mouse left, move my mouse right, the paddle is also moving left and moving right. That's the challenge, that's the problem, and our solution has a number of steps to it. First of all, we need to find the position of the mouse as it moves. So we need to say, if the mouse is here, what is the position on the screen? If it's there, what is the position, and so on. We need to convert the mouse's position into world units as a proportion of our total screen size. And then to have it in world units, why in world units? Well, if we click on our paddle here, on our paddle, we can see it currently has a position. Its X position right at the moment is 8.39. That would be based upon wherever its pivot point is, and the pivot point for our paddle is right in the middle. If we move it all the way over to the left, you can see when it bumps to the edge of the screen, it's still at position 1. That's because our paddle is 2 in width, and our pivot is in the middle. If we have it at position 0, that is where it would be, and it's a little bit half off the screen. So we don't want that, but that is just showing you that as we move our paddle left to right, we need to know the number in the world units, not in some other arbitrary kind of number. And then final step is to update the paddle's position to be whatever the mouse's position currently is. So if our mouse is at position just here, then our paddle needs to know, oh, I need to be in position just there as well. Okay, so that's our problem and hopefully our solution. Let's click on paddle, and we want to add a component that we will call paddle with a capital P, paddle. New script, create and add. Wonderful, it's popped up Visual Studio. I haven't opened it yet. I'm just going to drag my script into my script folder, as good organized folks do. And Visual Studio, it's been a bit crazy on me. It keeps wanting to open up. It's like, come on, Rick, hurry up and open me up. Okay, Visual Studio, now's your big chance. Here we go, your moment in the spotlight, Visual Studio. Okay, cool. What we'll do first of all is we want to, in our update method, and why the update method? Well, as we're moving around our paddle, every single frame we want to know, where am I, where am I, where am I, where am I? That's why we're using update. So within update, let's start off just by finding the position in the XY coordinates of the mouse. Let's start by printing to the console by typing debug.log. What are we printing in the console? Well, we're going to start by printing input.mousePosition. That is how we can see exactly where the mouse is positioned within our XY coordinates. Save that, back over into Unity. We can open up the console in this case. So just click on console, croaky, and then click play. I'll expand my game window a little bit so we can see what's going on here. Expand the game window. Oops, and of course we're going to have game over as soon as my mouse hits the lose collider. For now, I'm going to click on lose collider and toggle it off. So once I click off, that means that will no longer take place. The ball will just go flying past and not actually touch the lose collider because it's hidden for all intents and purposes. Okay, click play again. Now you can see updating down here in my console when I'm within my game screen here, which is along here. Bottom left, we should be somewhere around 0. We've got 3 numbers there, 0 all the way over to the right. Cool. So the first number is our X coordinate. The second number is our Y coordinate. And the third number is the Z coordinate, which should be 0 because we're not going into and out of the screen. So it's giving us some numbers. As we move up, the X is moving up. As we move up vertically, then the Y is moving up and down. Cool, so we know where the mouse is on the screen. Very cool. What's the next step? The next step is for us to say, what is the mouse position just on the X-axis? And the way we do that is by saying .x. That's narrowing it down. We could say .x or .y or .z. We're saying in this instance, we just want to know, in terms of input, the mouse position for the X-axis. Save that, back over into Unity. Now we should be printing out just one value instead of these 3, and that should be the X-axis. Click on play. Wait a moment while it's thinking. Okay, we've got just the one number, and you can see as I go up and down, if I can keep it very still on the X as I go up and down, it's not really changing very much. It's staying in the very low single digit, point something. If I head over to the right, then it goes up to about 700. Okay, that is very excellent. Now, what next in terms of finding our mouse position? Well, we want to know if our screen size was different resolution. We want to know where we are relative to the overall screen size without having to know, oh, this is a 1080 width or this is a 600 width. We don't want to have to plug that into the system. We just want to know. So the way we do that is we take our mouse position on X as a proportion of the overall screen width. We have a mechanism to understand that, which is saying our input.mouseposition.x divided by screen.width. That's how we access the width of the screen. The width of the screen will be, you can see here, current width of the screen window in pixels. We save this, back over into Unity, click on play, and as I move, it should be giving me a value from 0 up to 1. Okay, so we now have this as a percentage. If I'm right in the middle, it should be around about 0.5. Okay, a lot more useful. And the final step we want to do in understanding where our mouse is to say, well, we know that there are currently 16 units. This is the way we've set up our world, so that we have 16 Unity units from left to right. This is the way we set up our camera. If you remember, click on camera, you can see a size of 6, which is the vertical. That means that total vertical is 12. We have a 4:3 aspect ratio, so that means our width, given that our camera is 6, our width is 16. Half of our width is going to be 8. Okay, we covered that in the previous lecture, so I'm not going to go too slow on that. Hopefully it still all makes sense to you. And the way that we say how's our position relate to our units is to times this by 16, because that's how many Unity units we have from left to right. Now, alarm bells should be going off. We never want to put a number, unless it's a 0, a 1, or a 2, because they have a specific meaning or a purpose to them. We never want to put a magic number like this right in the middle of our code. So a mini challenge for you, I want you to serialize our screen width in units as a variable, so that we can use that variable instead of using the 16. So mini challenge for you, pause the video and give that a shot. Okay, so up the top of our script here, underneath class, we are going to type serialize field. Serialize field. We need to make this a float because we have decimal points. Whenever we have dot something something something, we need, which are decimal places. Another way of saying decimal places, we need to make it a float. And I'm going to call mine screen width in units. So it's super duper clear exactly what's going on. And I'll initialize that at 16. So down in our print statement down here, we will say screen width in units. Okay, and it knows screen width in units. What's that? That is 16. And we save this, jump back over into Unity. We can see that when we find our paddle, which is currently where our paddle script is, we can see screen unit width 16, and if we happen to change that, we can simply go in and change it in here. If we thought, oh, our camera needs to be a little bit further out, then we can change it pretty easily. So let's just have a look at our coordinates now to round out our section of talking about coordinates. From the left, it should start off at 0. As we move to the middle, it should be about 8. It is, and then over to the right, it should be 16. You know what, while I'm here, I'm going to turn off my next level button. I don't think we're going to need that. Now that the ball hits the lose collider, we can get to the next level pretty easily. So within Canvas, it's still called success button, naughty me. I'll just toggle that off for now, just in case we need it later. Okay, click on save, looking pretty good. The next part of what we want to do is to actually move our paddle to a different position on the screen. First step we need to do in that, which is to just move the paddle around somewhere else. Okay, currently the paddle is at the 6, around about 6 and around about 0.3. I'm just going to get my y-axis here to be exactly where I want it, 0.25. Okay, so it's sitting nice and flush on the bottom of my world. That looks nice. The x-axis doesn't matter so much, but we'll put it at, I don't know, for illustrative purposes, we'll put it at 5. So our position is 5 and 0.25 currently for the paddle. Now back in our script, let's have a look at this. We want to, under update, we need to move our paddle to a different spot. And the way we do that is with a vector 2. So what I mean there is vector 2. What is a vector 2, I hear you ask? A vector 2 is a way for us, a compact way of storing x and y coordinates. That's how we'll be using it. Which x and y coordinates? Well, if you look at the position, all game objects have a position. They have an x, a y, and a z. Now, because we're doing a 2D game, we don't need to know z. It should be 0 or should be unchanged. So instead of having a vector 3, which would use x, y, and z, we just need a vector 2, which is going to store the x position and the y position. X position sounds funny if you say it very fast. Sounds like the paddle is running around getting its clothes off, but not that sort of x position. So we need a new type of vector2. I'm going to call this paddle pos. We could call it paddle position to be thorough, but I'm going to call it just paddle pos because we know what that means. Save us a couple of letters because it's still very clear. Pos is the universal way of saying position. Equals, we have to use the keyword new so we can construct a new vector2. We need to start off by saying paddle pos is a variable. It's typed vector2. And what are we going to say the x and y values are? Okay, so new vector2, that is how we construct this variable of type vector2. Vector2, paddle pos equals new vector2. And then in brackets, we're putting in the x and the y coordinates. And we need to use floats. So for here, I will say our values for x is, say, 10. We put an f whenever we use a float. We have to put an f on the end. I didn't mention that up the top here, but a float has to have an f after the number, comma, and for our y, what should we do? Well, we'll say 4. Okay, so here we have a new vector2 that will be in this position. We're saying go to this position here. And how do we do the go to? Well, specifically, we say the transform dot position equals, what do you think it equals? It's going to equal this variable we just created, which is paddle pos. Now, why is it transform dot position? If you have a look on your game object, you see that the game object here, the paddle game object, which we currently have our script component. So our script is talking about, it's saying, I am currently a component of this paddle. And this paddle has a transform component. See up the top here, transform. And within transform, we have a position. So we're referring to the transform dot position. And when we're saying, what are the current values of transform dot position? We're defining them as paddle pos. What is paddle pos? Paddle pos is currently a vector2 of 10 and 4. So therefore, we're saying the transform dot position will be 10 and will be 4. Okay, let's save our script and make sure that that actually is the case when we click on play, that our paddle should go blink up to 10 and 4 on our screen. And it does. You can see that it's jumped up to a value of 10 and jumped up to a value of 4. So we're controlling our paddle's position within the world from our script. Excellente. Now what do we need to do? Well, I'm going to show you one more thing, which is how we can say, use the current position that you're in now. Use where you are now. So when we say our vector2, paddle pos equals new vector2, and we've put in very specific values in here, if we would type in instead the transform dot position dot x. Remember, the first value here is an x and the second value is y. Now, what this will say is wherever this particular game object currently is for its transform dot position dot x, that's what I want you to make the new vector2 as. So in other words, stay where you are on x and then move to 4 on the y. Save that, jump back in here, click on play. It should just move up but stay on the same horizontal axis. Excellent. As it's done, and nicely it's juggling the ball there. Very cool. And so there's one final step, and that is going to be your challenge for this lecture. The challenge is to move the paddle. Set the paddle's vector2 so that it is on the x-axis where the mouse currently is, and we've set that up as a variable, and on the y-axis where the paddle already is. Give it your best shot, and I'll see you back here when you have given it your best shot. Previously, we were just printing this out. We're printing out where the mouse currently is. Let's make that into a variable, so then we can use that variable for good rather than for evil. Let's call this variable, it needs to be of type float, and we'll call it mouse pos in units, just to be very clear that it's to do with the screen units, hence this last bit here, and it's to do with the mouse position. And then we need to remove our parentheses that we had around our debug code just here. Save. We've got all of our framework in place. What we need to do in our vector2, which is updating on every frame, we want to say that the x position should be our mouse pos in units. So we want it to be wherever the mouse currently is. That should be the x for the paddle. Why is it the paddle? Well, this script, this class is currently a component of the paddle. That's why we're moving the paddle. We're moving it down here with the transform dot position of the paddle. And then the y value in here, we want to have the transform.position.y to say stay where you are on the Y. Let's save, back over into Unity, click on play, and then move my game window, and I missed the ball as it went flying through, but you can see that as we move our mouse, the paddle is lining up exactly with where the mouse is. So success, we've taken the input of the mouse and we've used that to move a game object left and right on the x-axis. Great work! In the next video, we're going to deal with how do we stop the paddle going woo way off the screen. Great work, and I'll see you very shortly.